Okay, today I'm going to go over a A203115 board that had no backlight. The LVDS cable was visibly burned, the fuse was blown, and there was no light on the screen as a result of liquid damage. I'm going to go through the troubleshooting process. So the first thing that you do on a board that has no backlight, before anything else, before replacing the fuse, because replacing the fuse can be a complete fucking waste of time if the short is still there, is to actually test the circuit. Now, where we start, excuse me, it's still morning, is where the backlight circuit started. See, I don't give a fuck if I flip the fan over because I know how to resolder the connector. And we start right over here on this one. So over here is where the backlight ends. So let's go over here. See that? Where it says PPV out SW LCD booklet. You can find this crap on Mac Rumors. There's a ton of people that have uploaded these little pages and schematics on the Mac Rumors forum. Anyway, so you can see right over there that C9799, C9797, and C9796, and on the opposite side of B9701 are where the backlight circuit all terminate. So that's right here. I like to have this stuff open in a split view, so here's my other screen. See, and it tells me that C9799 is right over here. So I actually have a wire attached to that. I'll get to that later. But a quick way to test this shit, let me try to get this all in view since I don't have the tripod, is using a multimeter. So I put this in the diode mode. You can either do a resistance test with ohms or a diode test. I like the diode one because it's a little quicker. So you put the positive to ground, then you put this over here, and this is the measurement that you should get. So this is a diode mode measurement. What a multimeter diode mode measurement does is it measures the voltage drop across a diode. Now, a diode is kind of like a check valve in plumbing. You know how they have those valves where it'll only allow the water to flow one way, but it won't go the other way? Well, just putting that inside the pipe causes there to be some sort of resistance because you've put something inside the pipe that was not there before. And the same is true for a diode. Any diode that only allows electricity to pass one way, it'll allow it to pass just fine, but there's going to be a very small voltage drop where in the diode because there's something in the diode that's keeping electricity from being able to flow back the other way. And usually that's about 0.5 volts. So the reading that you see here on my backlight circuit when I put the positive on ground and the ground at the output of the backlight circuit is 0.534. And that's a proper measurement. Now, if your backlight circuit is fucked, you'll see one of two things. Very rarely you'll see OL, which is, means that there is no, it's not measuring any voltage drop. And sometimes you will see 0.1, 0.2, which means there is a voltage drop, but there's a very, very small voltage drop. And that is also no good. Most commonly you'll see something like 0.1 or 0.2, which means that somewhere in the backlight circuit there is a short to ground. And that's what I had here. So replacing the fuse again, if you're going to replace a fuse and the circuit is still shorted and you're not getting a 0.499 or 0.58 or 0.53 measurement, it's completely pointless. Again, depending on your multimeter and the leads and your test environment, you may not always get 0.531. Again, if you get a 0.499 or whatever, most of the time it's just fine. But if there's still a short, you're fucked. And here there was one, and it was driving me nuts. So that's what this little wire is here for. This is a piece of Cat 5 cable. It's solid core. It's very thin, so it's easy to work with, but it's also solid enough that it will carry a high current. So what I did is I attached it to a power supply. So here is a G5 power supply. You can get a test bench power supply for like $150 or $200. I use this because it was free. Some douche left off this G5 tower here and never picked it up, which means that power supply is mine. He was one of those people that he brought it in. This thing's from fucking 2003. And he's like, I wish I knew you didn't work on this before I came all the way down here from the Upper East Side. I came down here from the Upper East Side. I'm like, dude, I don't care if you came from Mars. I don't work on 11-year-old computers that were out when I was a freshman in fucking high school. And if coming all the way to the East Village, all the way from a quarter mile up on the Upper East Side, is that much of a fucking inconvenience to you? How about you make a goddamn phone call to ask, hey, do you work on antique horse shit? And then I would say, no, we don't work on antique horse shit. You would save yourself the time. Anyway, I don't know what is actually wrong with this. It just turns on and has nothing on the screen. And my receptionist kind of thought I was being a little hard on the dude at the time. So I said, watch this. We're going to call. We're going to say it'll be $90 to fix your computer. I don't even know what's wrong with it. I don't care. I'm doing this to prove a point because I know he's not going to say yes. So we call and say it'll be $90 to fix. And he's like, like, you know, like he had a fucking heart attack. Like I just slit the throat of his firstborn son. Which proved the point that it is completely worthless to work on old horseshit because people are simply not willing to pay for it most of the time. And even if they are, you're never going to find shit for it. Anyway, the power supply is totally fucking fine. And it's been more than 45 days, and he hasn't picked it up. So this is now my bench power supply. So back to my point. So I need to find out where the short is. Now, as you can see on my board here, I have this big honking wire coming out of it. Again, not giving a fuck if I knock the fan connector off the board, because I have spares. So this is my wire. Now, the point here is there's a short between the output of the backlight and ground. Somewhere in this circuit, based on the measurement that I got, which at the time was not 0.531, it was like 0.1, there was a short between the output of the backlight and ground, somewhere in this circuit. And you can test each component individually, but sometimes there can be millions of little places. Like, just look at all the components on this board. Again, if you're working with one individual circuit or one individual part, you may be easy to find the short, but sometimes you really can't find it anywhere. And that's where I found myself with this board, which is why I put this wire on it. So here's the point of this. This output here is shorting to ground. So the output of the backlight, which it's like 12 to 27 volts, is shorting to ground. So what I decided to do with the board off is put the 12 volts of this power supply, like so, into the 12 volts of the backlight. Now, since that circuit is shorting to ground, that means that the 12 volts from the power supply is going to show up on ground. So what I did is I took a bunch of LED strips that work off of 12 volts, and I put the positive of the LED strip on the ground of the board, because I know that the 12 volts from my power supply is flowing to the backlight circuit. The backlight circuit, because it's fucked, is shorting to ground, which means my 12 volts will show up on ground. So I attach the positive of the LED strips to here, and then I attach the ground of the LED strips back to the ground of my power supply, which completes the circuit. Now, what this means is that in order to power my LED strips, the 12 volts has to flow through whatever component in the board is shorting the backlight circuit to ground. So whatever is shorting the backlight circuit to ground is going to be in for a world of fucking pain when it has to pump 10 amps through it to power the lights. Now, what will usually happen in this scenario is whatever component on the board is shorting my circuit to ground is going to turn red, it's going to get boiling hot, and on rare occasions it may even just pop itself off the board, which is pretty cool. Now, in this case, it did not do that. By the way, a note of caution, if you're trying to test a 3-volt circuit, obviously do not plug in fucking 12 volts because you are going to sodomize it. If you're testing a 5-volt circuit, don't put 12 volts in, you're going to sodomize it. This is a circuit that starts with 12 volts and boosts it to 27, so I'm totally okay with putting 12 volts into it because I know that it's meant to handle it. Anyway, so I put that in, and I wound up adding like 3 LED strips, which is 15 amps, and nothing was even getting remotely warm, and this was just starting to piss me off. Now, the short in this one was actually in the LCD connector. So once I removed this LCD connector, it went away. And the fucked up part is usually you can see under a microscope if there's a short. Usually you can. If you put a stereo microscope over here, you'll see some stupid little fucking pin or piece of solder that burned and is now bridging 2 pins together, which is causing the short. In here, I really did not see it. It was not there. I removed it with the Hacko, and the short went away. And I put a new one on there. And I put a new one on there, and I got that 531 reading. So here's my soldered LVDS connector. As you can see, I suck at soldering these things. It's fucking horse shit. Shameful. Let's get a close-up view. It really does suck. Yeah, I actually fucked up soldering one of those pins, but I don't care. I looked at the schematic and it said that that pin is not connected. That's one of the most beautiful feelings in the world, when you fuck up something and you realize the thing you fucked up completely doesn't matter. And it's on there pretty sturdy. I can rip at it and nothing's gonna move, so I'm happy enough. Anyway, I put the new connector on, and I get my 0.531 measurement. Well, beautiful, because after that point I had replaced the fuse, the LED driver, and drove myself nuts looking for a short that was actually in the connector. that's why it wasn't getting hot. You see, a resistor or a transistor, which is nothing but a transforming resistor, they do their job by emitting the extra power going through it as heat. So naturally, a transistor or a resistor, if you're skull fucking it with power to power LED lights, is going to get really, really hot. Whereas a big hunkin' piece of metal, it's not going to get hot. I mean, this is not going to get hot unless you put, 300 volts, like hundreds of amps through it. But this is not going to get hot with a bullshit little 12 volts and 10 amps. Like, let's say a tiny little capacitor is, but this is not. So that test was completely useless. But after replacing that, I turn it on, and there's still no fucking backlight. So now I'm just starting to get annoyed. Now, even because my measurement is fine, I get the 12 volts across the fuse. So now we move on to the next part, which is checking the backlight enable voltage. On this machine, don't go to sleep, ThinkPad. On this machine, and pretty much all of these, is also right next to the LED driver, there is a voltage divider network there's a voltage divider network that tells this chip when to turn on. So I mentioned this in another video. You can look at the last backlight video I did to learn what a voltage divider is, or you can just Google it and look at a YouTube video where they explain it much nicer than me with cute little animations and shit. So these two resistors here are part of the voltage divider network, and over here on the left side of each, you're supposed to see 3 volts, and that's supposed to be going to the backlight IC. So let's just get a close-up of this on the screen here. See backlight enable, R9731 and R9715 created. And I measured there, and those resistors measure what they're supposed to, but there's still no fucking backlight. So then I went to the left a little to see where that comes from, and it says on the screen here, that comes from PP bus SW LCD booked power per. I like to actually pronounce it the way it's spelled on the screen. It's just kind of like my little entertainment when I'm torturing myself at 1 in the morning. So when I search for LCD booklet per, which is what powers that little voltage divider network that creates the 3 volts, I see that that's powered through this transistor here. Now this transistor opens based on the signal from this voltage divider, which opens based on LCD booked enable and booked pult recital. I didn't even bother going to those ones. I just said, let's check this transistor. It looked fine. Then it said Q9707. So I looked for Q9707 on here, and that's this shit here. You can't see it because I'm not aiming at it. Fuck. Here we go. Here we go. So that's that. Now you can see that there's some little residual flux because that pin and that pin for some reason had some kind of solder blob or corrosion or some sort of fuck shit piss on it. And because of that, it was actually shorting those two pads together. And let's see, I actually forget what those two pads are for, so let's look it up so I can tell you. Every so often, and now come back for one fun. Every so often, easy motion. Yeah, so LCD backlight enable and LCD backlight disable. So the gate was actually shorting to the source of Q9707, which is why you didn't get the backlight voltage. So once I fix that, PP bus SW booklets power put out 12 volts, which allowed R9731 and R9715 to create 3 volts out of 12 volts in order to send 3 volts to backlight enable of the backlight IC, which told it to turn on. And at the end of that, it actually worked, which is pretty cool.